Hello my dear friends, welcome to IMS Academy. My name is Sourav Upadhyay and in this video we are going to discuss some very important pattern based PYQs of thermodynamics. Yesterday I took GATE 2023 HT plus IE questions. Today we are going to discuss a new way of which is what I am calling a pattern based. What pattern? Now you know that in thermodynamics the piston cylinder questions are going to come in a one of the favorite topics for GATE, right, which is based on the first law of TD. So what we are going to do today, I am going to take last 4-5 years of TD questions which are only piston cylinder based, right, so that we try to derive a pattern of solving such questions, and in future when a piston cylinder question comes, what approach should we follow for solving such questions, right. So without wasting any time, let us straight away get the job done. Okay. So my dear friends, we will be starting with 2018. We will be starting with 2018 and this is the first question that we are going to discuss. Air is held inside a non-insulated cylinder using a piston of mass 25 kg and area 100 centimeter square and stoppers of negligible area as shown in the figure. The initial pressure Pi and temperature Ti of air inside the cylinder are 200 kPa and 400 degree respectively. Good evening, Matan. The ambient pressure P infinite and temperature are 127 degrees respectively. The temperature of the air inside the cylinder at which the piston will begin to move is what? So this is the scenario which is given to you. So my dear friends, see one thing, one approach I am saying you, and that will work out in the piston cylinder and that will help you a lot. You need to guess or you need to determine what is the actual process that is going on at any time inside the cylinder. For that, FBD is the one of the most important things that you should do it. If you do the FBD, it will give you a very clear idea about the pressure, and due to that you will be able to guess that what is the process that is going on, and based on that you will be finding, if he is saying work, you will be finding work, if heat, so you will be finding heat and whatever, right. In this case he is asking simply the temperature at which the cylinder will begin to move. Now my dear friends, at every state is the equilibrium state, and at every state the forces are balancing each other. So this is the state of the piston that is given to you, and you can say that the forces which is on bottom side of the piston, for example this is the piston. So forces are there at over here, some pressure is there from above, atmospheric pressure is there, that is P naught into area, and the weights of the piston will be there, and from below the initial force, initial pressure of the gas into area. This is the force that is there. So if you just try to apply the FBD, so obviously the forces, now here stops is also there, so I should draw stops also. This is also exerting some force. So right now the forces will be balanced if you try to find out whatever you want, for example the force exerted by the stops or anything, so it will be balanced, like it will be balanced. So this pressure he has given, like Pi is given is 200 kPa. 200 kPa is the pressure, and temperature he has given is 400 degrees centigrade. So if you convert in 673 Kelvin, 673 Kelvin in temperature. Okay, ambient temperature is given, the temperature of the air inside the cylinder at which the piston will begin to move, and what is saying initial pressure inside the cylinder is this and this, the ambient is this. Okay, now my dear friends, see one thing, now at this place how will the forces are balanced right now, how will the piston move down? When you extract some heat from there, that means if you cool, then only the piston will start coming down, yes or no? When you start extracting some heat, then piston will lose some heat, the gases will contract. When the gases will contract, the piston will start moving downwards. And never ever think that all the processes are happening in an instant. Instantaneous process are not considered while when we are talking about equilibrium. We assume that the processes are happening at every state. We have to draw the one, it's happening very slowly. So every state is like very quasi-static, the processes are quasi-static, very slowly, so that at every state you are able to draw the FBD and you can plot on the graph. So these all concepts, why I am discussing, because these are going to help you a lot in your piston cylinder questions, right? So now my dear friends, at this state if you start cooling, so instantaneously the piston will not come down. Okay, so you have to determine that what is that pressure at which the piston will start coming down. Are you getting this point? So right now the piston pressure, that the pressure of the gas in at this end is 200 kPa, Now my dear friends, when the piston will just start to move, so it will leave the stopper, yes or no? And when it will leave the stopper, definitely some forces needs to balance, so this side pressure will kind of reduce. So I don't know what is the pressure at this state, so let's say it is PF and area is A, that means the force is this much, and from above atmosphere is there, that is P naught into A, and the weight of the piston is also there. So right now what I have told, that when the piston just starts to leave, the stopper will stop exerting forces from above. So at this place, if I try to equate or apply the force balance, weight is nothing but M into G. So this will help you determine what is the pressure at which the piston will just start to fall down. So PF is equal to A and A gets cancelled, so P naught plus mg by A. So what is P naught? So P naught, so P infinite he has given, that is 100 kPa. So that is 100 kPa plus, what is the mass of the piston? 25 kg, and G value is 10 meter per second square, and area of the piston is 100 centimeter square. So 100 by 10 to the power 4, so this I am writing it over here, 100 by 10 to the power 4. So mass M into G, that is Newton per meter square, that will come as Pascal. So again you need to divide by 10 to the power 3, so to make it kilopascal, and once you do this, we are going to get this and this will get, everything will get cancelled, and finally we will be left with 125 kPa. So my dear friends, this is the pressure, 125 kPa is the pressure at which the piston will just start to slide, just start to slide. And mind it, all this is happening while the piston is still at this place. That means it is indicating that it is a constant volume process. Are you getting this point? Just before the piston will, or just till the moment the piston is starting to fall down, all this is happening till heat is being lost at constant volume, right? And you know that when it's an ideal gas, because air is mentioned, when it's an ideal gas, and if it's a constant volume process, so I can say that P1 by T1 is equal to P2 by T2. I need the value of T2, so P2 by P1 into T1. So what is the final pressure? The final pressure is 125 kPa. What was the initial pressure of the gas? That is 200 kPa. And the initial temperature was 400 degree, that is 673 Kelvin, right? So if you solve this, 420.63 Kelvin will come. Why? Because make sure that this relation is any ideal gas equation you are using, the temperature must be in Kelvin. But he is asking in degree centigrade, so simply subtract 273 from here and 147.63. You will get answer 147.63 degree centigrade. So he is asking 2 decimal places, so 147.63 degree centigrade will be your answer, right? 147.63 is your answer. So what is the idea, what is the what approach can we just, or you can say algorithm can we fix? In piston cylinder, drawing the FBD is the key. It will guide you and it will tell you that what processes is there, and based on that you can just find work done if he is asking or whatever he is asking. So I hope you have got this approach, and this is the answer. 147.63 is the answer, right? Okay. Moving ahead, this is the question from 2020. So earlier question was of 2018, this is of 2020. Air is contained in a frictionless piston cylinder, so it is indicating that the process is reversible as shown in the figure. So this is the setup he has given. The atmospheric pressure is 100 kPa and the initial pressure of the air in the cylinder is 105 kPa. The area of the piston is 300 centimeter square. So all this data will be given. Heat is now added and the piston moves slowly from its initial position. So when you give heat, the piston will go upwards until it reaches the stops. So until it reaches the stops. The spring constant is given as 12.5 Newton per mm. Considering the air inside the cylinder as your system. So this is your system. The air which is there inside the cylinder is the system. So what is the work interaction? What is the work interaction over there? So my dear friends, see, right now you must be feeling that it's what processes are taking place, what we should do, what we should not. But if we draw the FBD, we will get a very clear idea that what is actually going on. So if at this position, if I draw the FBD, that means at the initial position, so this is the piston and on this side air is there. So has he given? Yes, initial pressure is given as Pi into A. Now remember, we are not equating the pressure, you are actually equating the forces. So Pi is given as 105 kPa. And on this side atmosphere is there. So P naught into A is the force, and P naught is given as 100 kPa. So P naught is given as 100 kPa. So obviously 105 and 100, so where is the rest force coming from? It is coming from the weight of the piston. It is coming from weight of the piston. So at this place, that is the initial position, if I just try to draw the FBD, so on this side the pressure is, the force is Pi into A. On the upper side it is P naught into A plus the weight, I am simply writing weight. So it's not that I need to calculate the weight right now. Pi I can just write as P naught into A plus weight of the piston by area. That initial pressure is given as 105. So see my dear friends, P naught is constant, area is constant, weight is constant, and A is constant. So right hand side everything is constant, so left hand side is also constant, and that means what? That now there is no pressure or no external force above the piston or above the air till it reaches the spring. That means for a distance of 8 centimeter there is no external force that is acting on the piston, and considering this equation, what you can say that it is a constant pressure process, that it is taking place for the next 8 centimeter, for the first 8 centimeter. Only after your 8 centimeter, only after reaching first 8 centimeter, then the next 8 centimeter will be encountered by the spring, and then the external forces will come into picture, right? So if I just try to draw the PV diagram over here, so this is P, this is V, so this is, let's say, V1, this is, let's say, V2. So at a pressure of 105 kPa till the distance is 8 centimeter, it is undergoing a constant pressure process, that is expansion. It is undergoing expansion, right? So since they are asking you work, I can very easily find the work by finding the area under this, area under the diagram. Area of the piston they must have given, that is 300 they have given. So I can find PdV work. Now after it touches the spring and till the time it reaches the stop, that is the thing which you need to consider. So this is the spring, and when the piston touches the spring, so what will happen? The spring will try to give some resistance to the piston. It will give some resistance. What is the spring force? Kx is the spring force. So when it will give the resistance, and since forces needs to balance, so the pressure over here, that is on this side of the system, your air will start changing. Earlier there were no resistance, so the pressure was constant. Now since the spring will start offering some resistance to the air which is trying to expand, so due to balance of forces, the pressure on this side will also start changing, rather more force on that side, so the pressure will increase, right? So if I just try to draw the FBD, so on this side spring force is there, that is Kx, and P ATM into A, that is always there, and the weight of the piston is there. And now my dear friends, since additional Kx is coming, So I should say Pf into A, that is the new pressure, or P2 into A you can say. P2 into A you can say that it is coming into picture. So what is going, you need to determine what is the P2, okay, or you need to just see that how is P2 varying. So I will draw the FBD. So forces on this side, that is P2A, is equal to forces on the from above plus weight of the piston and plus Kx is there. So if I just try to find P2, so it will be P ATM plus weight by area plus Kx by A. Now my dear friends, from the first equation, what I can say that P naught A plus weight by A is nothing but Pi. So this thing is nothing but Pi or P1 you can say, Pi or P1 same thing only, plus Kx into A and P2. Now this relation is giving you a very clear idea that pressure is constant, P1 is constant, area is constant, K is constant, but X is constantly changing. So pressure is proportional to your X. Pressure is proportional to your distance. That means what? That as the distance is increasing, your pressure is also increasing, right? So as I said that drawing the FBD is going to show you a very clear path that how is pressure changing, and from there you can just get an idea that what is the pressure that is occurring. So if I draw over here, the pressure is increasing in a linear fashion. So let's say I am going till here. Now he is saying that we have to add the heat. Why the pressure, why the piston is going up? Because you are providing heat, expansion is taking place, air is trying to expand, and as such it is pushing the piston upwards. Now he is saying I will be giving heat as long as the, until it reaches the stop. When it reaches the stop, I will stop giving heat. So you need to find the pressure when it touches the stop, and when it will touch the stop, it will touch the stop at V3. That means the next 8 centimeter it will be touching the stop, and that is what, that is when we need to get the pressure. So this is the X relation with you. I will simply substitute X equal to 8 centimeter and I will get to know what is the P2 value. So P2 is what? P2 is P1 plus Kx by area. X I will substitute 8 centimeter. That means everything should be in SI unit. So P1 is what? P1 is 105 kPa. 105 kPa plus. Now K value is what? 12.5. 12.5, but Newton per meter, meter you should keep. So 1 millimeter is 0.001 meter. And X is what? 8 centimeter. So 0.08 meter I should keep, and divided by area is 300 centimeter square. So I should keep 300 into 10 to the power minus 4. So Newton per, so this will give you Pascal. So I should again divide it by 1000 so that it becomes kilopascal. So calculations you can do, my dear friends, and I'm just writing what is the final pressure that we are going to get, and you will be getting approximately 138.33 kPa. After solving this, we will be getting 138.33. That means I know that what is going to be the pressure. So this pressure is what? 105 kPa. Till V2 it took as constant pressure. Now when it reaches the stop, it will be 138.33, right? So when you know the pressure, why did I find the pressure? Because area under the PV diagram will give you the work, right? And it is for reversible. So clearly he has mentioned frictionless, that's why I can use PDV work, that is applicable only for reversible. So now my job is only to find the area under the curve, and that will give me the work done. That will give me the work done. So let's say this is the rectangle area, that is W1, then this is the trapezium area, which is W2. So what is W1? That is P into dV. So V2 minus V1. So P0 is 105 kPa, and V2 minus V1, that means the change is 8 area into 8 centimeter. So finally 300 into 10 to the power minus 4, that is your meter square, and centimeter 0.08 meter. So that will make it meter cube. So this answer will come in kilojoule. This answer will come in kilojoule, and it will come 0.252 kilojoule. This will come as 0.252 kilojoule. Now for the trapezium, I can use W2, I can use half into sum of the parallel sides into distance between them. So parallel sides is 105 plus 138.33, that is sum of the parallel sides, into distance between them is the volume. So the volume is again area, that is 0.08 is the length meter, and area is 300 into 10 to the power minus 4, that is meter cube. So if you solve this, my dear friends, you are going to get 0.291 kilojoule. 0.291 kilojoule. Why kilojoule? Because I have kept kilopascal, right? So W1 is this, W2 is this. So net work will be, or total work will be, W1 plus W2, and if you add both, you are going to get 0.543 kilojoule, but he is asking in terms of joule, so it will be 543 joule. 543 joule. 543 joule. So again, what helped me in this question? Drawing the FPT at various points has helped me determine what is the relation of pressure with respect to whether it is constant pressure work, whether it is not. So this is what FBT is going to be a very important thing when you tackle piston cylinder questions, right? Let's check the next question, that is GATE 2023. Consider a fully adiabatic piston cylinder arrangement as shown in the figure. The piston is massless and the cross-sectional area of the cylinder is A. The fluid inside the cylinder is air, which is considered as a perfect gas, with gamma being ratio. So all the story he has given, which you generally know. Gamma is Cp by Cv. The piston is initially located at piston L1. The initial pressure of the air inside the cylinder is this, P1 greater than P0, where P0 is the atmospheric pressure. Stop S1 is instantaneously removed and the piston moves towards L2, where equilibrium pressure is P2. What is the work done by the piston on the atmosphere during this process? So my dear friends, and options is given to you in the next page. So one very one mistake you can make over here is that, first of all, he has not told you what your system is going to be. So it's not that always this air will be the system. Your system can be this air also. And he is saying that what is the work done by the piston on the atmosphere. That means your atmosphere is going to be your system over here. Your atmosphere is going to be your system over here. So this is your system, not this. This is not your system. This is your system. And when you see what process is happening, so P0 is the pressure of the atmosphere throughout the process. That means it's a constant pressure process. And what is constant pressure work done? Constant pressure work done is P0 into del V. So P0 into del V, that means at 2 area is the cross sectional area, L2 minus L1. P0 into del V is P0 is this answer. So first you will think that it is an adiabatic piston, so that's why the work done by this air will be adiabatic. Yes, the work done by this air inside the cylinder will be adiabatic, but don't take adiabatic as the answer, because he is not asking you that. He is asking what is the work done by the piston on the atmosphere. That means this is your system, and this system is undergoing constant pressure process, that is P naught into del V is the work done. And P naught into del V you can apply for reversible, irreversible both, right? Okay, for irreversible also. Why? Because P naught into del V depends on only the initial and final points. So properties, it can be for irreversible, reversible both. So you can apply that. Why irreversible? Because he has mentioned the word instantaneously, so that will just give you an idea that it is irreversible. You might think that this is not applicable, but no, P naught into P naught dV, P dV can be applied for both. So B is your correct answer, my dear friends. B is the correct answer for this question, right? Okay. And now, my dear friends, finally the GATE 2024 questions which has come this year itself from piston cylinder. We will see this question also. So a piston cylinder arrangement shown in the figure has a stop located 2 meters above the base. The cylinder initial contains air at 140 kPa. So here 140 kPa in this air is there, and the piston is resting in equilibrium at a position which is 1 meter above the stop. Okay, stop. The system is now cooled. So this is your system. Clearly he has mentioned that this is your system. The system is now cooled to an ambient temperature of 25 degrees centigrade. Very good. Consider air to be an ideal gas with a value of gas constant this. What is the value, absolute value of specific work done during the process? So work done he is asking. Work done he is asking. Reversible, equilibrium he is, he has mentioned. So reversible work done formula we can apply, and what he is saying that it is cooled, that means heat is taken out. So at this point, my dear friends, you just try to see at this point, if I try to draw the FBD, after 1 or 2 questions you will need not draw FBD also. Here it is initial pressure of the gas, that is 140 kilopascal into area, that is the force. From above, atmosphere is there into area, and some weight is also there. Now when you are cooling the piston, this piston will start coming down, yes or no? Yes, it will start coming down, and at any point till it comes to the stop, at any point till it comes to the stop, if you draw the FBD, this FBD is going to be the same only. And what this is indicating, that there is no change in force from external, that means the internal force, internal pressure is going to remain constant. At any point when you draw the FBD of this piston till it comes to the stop, you will realize that at any point the upper pressures are not changing, and when it doesn't change, so the system pressure also doesn't change. That is the constant pressure process. Constant pressure cooling is happening till what time? Till the time the pressure, the piston reaches the stop, right? And why will the piston come down? Because he's saying that we have to cool. When you cool, you know that air will contract. When it will contract, so contraction will take place. When contraction will take place, so piston will also come down, right? Are you getting the logic? So my dear friends, so here also it was not needed to draw, but why I draw? So just to give you an idea that yes, it's a constant pressure process. So till the time it comes over here, so you can find the constant pressure work done. Constant pressure work done. Constant pressure work done is what? P into V2 minus V1. P into V2 minus V1, distance is given, okay, but area he has not given. Area he has not given. Area he has not given. So I can apply mr temperature, mr T2 minus T1, mr T2 minus T1 I can apply, but temperature I need to know, okay. So my dear friends, constant pressure, ideal gas is there, so always you should remember the equations, constant pressure, and what I can apply for ideal gas, V2 by V1 is equal to T2 by T1. So I need to calculate T2 value, that is T1 into V2 by V1, right? So what is T1 value? That is the original T1. Original T1 is 350 degrees centigrade, and if you just check 623 Kelvin, so that is 623 Kelvin. 623 Kelvin is your temperature in Kelvin into V2. So final volume will be what? 2 into area of the piston by initial is what? V1 is what? 3 into area of the piston, A and A gets cancelled, and when you calculate this, $415.3 Kelvin is going to come as your T2. 415 Kelvin is going to come as your T2. So now I know that when the piston will reach here, when the piston will just reach the stop at a constant pressure, the temperature will come to 415 Kelvin. But he is saying that the gas needs to be cooled down to 25 degrees centigrade, which is 298 Kelvin. So right now we are at 415 Kelvin, and once the piston comes over here, still it is further cooled. That means at this place, piston is not going down because stop is there. So at this place, constant volume process will take place, right? Constant volume process will take place. So constant volume, so from 415 to 298 Kelvin, the cooling that will occur is constant volume cooling. But you know, my dear friends, that constant volume work done is what? 0. Constant volume work done is 0. So actually you need not care about when the air is cooling at this place. Why? Because piston constant volume is PdV is 0. So I need to find the work done only during the constant pressure phase. That means from here to here. And this is what I have written, constant pressure. That means this is going to be your answer. So he is asking per kg. So mass will be 1. R value is what? 0.287. And what was the T2 when the piston just reached here? I calculated 415.3 Kelvin minus what is the temperature? T1 is 350 plus 273, 623 minus 623 Kelvin. So this will come out to be 415.3 minus 623 into 0.287, 59.6. This will come out to be 59.6 minus 59.6 kilojoule per kg. So but he is asking the absolute value, right? He is asking the absolute value. So simply the value will be 59.6 kilojoule per kg. 59.6 kilojoule per kg. So this is going to be your answer, right? One decimal place, so we will keep it 59.6. So my dear friends, in these 4 questions of piston cylinder that I have taken from 2018, that means last 6 years, whatever piston cylinder question came for mechanical in TD section, that I have taken. And one thing we are getting to conclude from every question, that drawing the FBD is going to give you a very clear idea, or at least most of the idea you will get, that what is the process, how things are going to take place, And once you know the process, PDV, if it's a reversible, area under the curve will give you work done. Something you will get a very clear idea. After that you will get the, the path, that how to proceed. But FBD you need to draw, then only you will be getting the clue. If you ask me what are the future scope of this problem in such cases, because once it has come, obviously he will not repeat the same. So future scope is something like, he can put some liquid over here in the future problems which is going to come. He can put some liquid over here, or he can put some oil over here, some extra weight over here. Then he might ask you, now you are seeing one thing, that in every question he is asking you what is the work done, work done, work done. He might also ask you what is the heat transfer that is taking place, right? So for heat transfer, work done you need to find anyway. If it's an ideal gas, you will be able to find internal energy also. So in that case you will have to use first law of thermodynamics to get the heat transfer. So till now he has not asked heat transfer, but I think that this is going to be the future of, if a good level, something, change if he has to do, then this might be the probable change that he can do. And why first law? For a closed system, because it's a closed system, so dW is equal to du plus dPdV, or dW he can, du plus dW, that is the first law that he can, using that you will be required to find the, the heat transfer, right? So these are the 4 questions. This is it in this session, and I'm sure that whoever are your friends, do share it with them if they are preparing for GATE, whether they are doing it by themselves or in any coaching institute. You can share it with them. This is going to benefit them a lot, right? So do let me know if any doubt is there in any of the questions, and if you specifically need some fixed pattern of questions of TT, HT, IE, or any SOM, anything, so you can just let me know, right? So here we are ending the session. These are the features of our live online program. 800 plus hours of live classes, theory book, exercise books, 34 plus hours of years of GATE question bank will be there, 12 mentorship sessions are there, 130 plus online test series will also be there. And my dear friends, let me tell you that GATE 2025 test series plus is available at just 3299, where you will be getting all these features, my dear friends. All these features, what? 130 tests, 33 years GATE PYQ books also you will get, doubt solving portal, online revision, score booster, post GATE guidance, and mock interview you will also get. So these 3 books and plus the test series obviously you will be getting. So you can consider joining this test series plus. So what is the difference if you take only test series and test series plus? So you will be getting all these things when you take test series plus. Obviously the most important thing is that you are going to get the GATE PYQs, where in the books you will be seeing multiple solutions, alternative solutions that have been provided, or video solutions of some important questions have also been provided. So all in all you are going to enjoy the GATE PYQ books, and apart from that all these also will be available at your disposal. You can consider joining the Telegram group, where you will be getting daily updates regarding job, then regarding daily quizzes will be given to you, and any extra notification which is related to any job or anything that you will also get, right? So you can join it. So my dear friends, in this session this is it. Next we will be continuing with such sessions every now and then, as I said. So every time I will be coming up with some important questions, and as I said that at this time you should solve as many as questions as possible. These 3 months are going to be very critical, and already most of the PSUs have already started releasing their job notifications. So gear up and start preparing in a good way, in a serious way, right? So let's keep it till here. We'll meet again. Till then, God bless. Take care.